Hello everyone, I'm Dr. Sneha Nair from LG Institutes of Applied Sciences, and today we'll be studying about semester 5 physical chemistry, paper number 303, unit 3, part B, which is called as polymer chemistry. Now, this entire unit in the last videos, pretty sure that you would have gone through it. So we had already completed the definition of polymer, the classification of polymer, and obviously the in detail theory of copolymer. Now we are going through according to the Gujarat University syllabus itself. So the next important question that has been frequently asked in your Gujarat University syllabus is biopolymers or the biodegradable polymers. So let's get started. Now, if we talk about the biopolymers or the biodegradable polymers, the very common understanding, as the name only suggests, is they will be such kind of polymers that can be broken into smaller segments. Now, if I want to break the polymers, entire polymer into smaller segment, I will always have to do what enzyme catalyzed reactions. We already know that biodegradable is anything which will, over a duration of time, over a span of time, what will happen is it will itself get degraded. The simplest example आपने देखा होगा कि जब आप कई बार fruits and vegetable के peel को बहुत देर तक रखते हैं कहीं पे दबा के, तो what generally happens is over a certain period of time it will get degraded on its own. Similarly, the second common example that you would have commonly observed is generally that कभी भी कोई चीज को बरी करके रखा जाता है for a longer duration of time, and then what will happen is because of a lot of environmental atmospheric pressure factors etc, also what will happen is they will then try to degrade themselves. So the polymers that can be broken down into smaller segments by the presence of enzyme catalyzed reactions. Now, how will you produce this reaction? So the required enzyme that I want to produce, that I want to have, is obtained by microorganisms. So what generally happens is we already know that, for example, एक carbon carbon bond का chain growth polymer है, ठीक है? So what I will do is that carbon carbon CC bonds are very much inert to the enzyme catalyzed reactions. So they will be what? Non-biodegradable. So what I'm going to do is I'm going to insert a certain bond into them, so that what will happen is they will then become biodegradable in nature, and they will then become what? They can be turned up into certain compounds which can then be easily broken down by enzymes. So simpler way, see for example I had a carbon carbon bond, okay? Now because we had a carbon carbon bond, what was happening is jitna bhi I want to insert, jitna this was tending out to be what? Non biodegradable. So the moment I inserted certain compound into it, so what will happen is these will then try to become what? Biodegradable in nature, okay? So now these biodegradable, the moment they're converted into biodegradable, so what will happen is when these polymers are buried as waste, so what will happen is whatever microorganism which is present in the ground, they can easily degrade the polymer. So the simplest example or the common example to understand the biodegradable or the biopolymers is, for example, what I'm doing is I am taking acetal. This acetal, which is CH2 double bond COO, CH2, CH2, this we are inserting into a free radical. Okay? So what will happen is they are undergoing a free radical polymerization reaction kind of stuff. So you can see here, this is a free radical. So the bond will break, and this turn out to be the free radical will shift here. So what will happen is the moment the bond is broken, so the CH2, CHR remains as it is. A bond is new bond is formed between a radical and the acetal group. So CH2, COO, CH2, CH2. Now you can see here that this bond which was present between an oxygen and the carbon, which is the adjoining carbon, that are broken, and that is then released into the free radical form. So what will happen is this reaction further can be written as CH2, CHR, CH2, C double O of this one, C double O, and then OCH2 double bond, OCH2, CH2 with a free radical is present. So the commonest, simplest thing that we can see is, if it's what we have done is we have added an acetal group to an alkene, and then they will undergo what? They are already undergoing a radical polymerization. So a new ester group will be inserted. This is a new ester group, which is C double O. That is inserted inside the polymer. That is then converting the entire polymer into a biodegradable polymer. The commonest example or the widely used example of the biopolymers or the biodegradable polymers is that of a dextran. Dextran आपने कहाँ देखा होगा You would have seen, if you have undergone some kind of accident, and if some stitches are taking place in, on that wound, so generally dextran is now taken into consideration, so that you don't have to go and get your stitches removed after a certain duration of time. They will itself get decomposed after the certain duration of time. This is the very commonest and the most widely used technique nowadays in the as the biodegradable polymers. So in the coming video, we'll be studying about the different types of the polymerization techniques. So till then, stay safe, stay healthy, and keep on revising. Thank you.